So welcome to today's lesson, which is on vectors and scalars. So there's three learning objectives for the lesson, distinguishing between what a vector is and what a scalar quantity is, appreciate the vector nature of a force, and then adding forces along a line. So the first thing we have to do is work out what a vector is and what a force is. So everything in the universe, everything physical, has to be described by a size or a magnitude and has a unit. So vector quantities also have a direction. So for example, velocity or acceleration. So velocity would be 10 meters per second, which is the size or the magnitude, but also direction, say 10 meters per second north. And a scalar quantity doesn't have a direction. So an example for that would be speed. So you'd be going 10 meters per second, but you wouldn't know what direction you would be going in. Or mass. It's 10 kilograms, but 10 kilograms north means nothing. It's meaningless. It's a scalar quantity. It's only involving the magnitude or size of that quantity. So how do we represent vectors? Well, we use an arrowed straight line. Okay, so for example, on the right, we have the displacement here, which is 50 meters east. So the length of the arrow is a determination of the displacement size or magnitude, and the arrow head points in a direction east. Okay, and the same there with the purple vector. We have a displacement of 25 meters. That's the length of the arrow, and the direction of the arrow is pointing in the direction of that particular vector. So the size of the arrow, the length of the arrow is proportional to the magnitude or size of that particular quantity. So you can also add vectors. Okay, so there's many examples there. So basically adding vectors is you just say, well, if they're going in the same direction, you're just adding them across the line. Okay, so 4 newtons right plus 6 newton right will be the resultant force of that. We'll be adding them together, which will be 10 newtons right, which is the top example. Okay, but you can also subtract. So for example, in the other example there, you've got the object. It's got a force moving 6 newtons to the right and 4 newtons to the left. So if you combine them, there's some cancelling out, and it would become 2 newtons to the right. Okay, because the original vectors are known as component vectors. You add the component vectors, and the overall answer, or the sum, is going to be the resultant vector. So we can also do that with forces. Okay, so if there's a number of forces acting on the body, they can be replaced by a single force. Okay, so for the example on the right there with 3 newtons and 2 newtons, you just simply add them up and it's 5 newtons to the right. Okay, because 2 newtons to the right plus 3 newtons to the right will give 5 newtons to the right in a sum. Okay, this is known as the resultant force. Whereas if it was 3 newtons to the left and 2 newtons to the right, then overall it will be 1 newton to the left, because the 2 newtons on the right would cancel out the 2 newtons to the left. Okay, so here's just to finish off some examples. So the box here will move only when the push force to the right is greater than the friction force to the left. If it is not, if it's the same, then it will move at a constant velocity or stay still. And if the friction force is greater, then it's not going to move at all. And then the plane will accelerate provided the engine force to the right is going to be greater than the drag force. If the drag force is greater, then the plane will not move forward. If anything, it'll actually move backwards. And then we have this car. If the brakes exert a resultant force in the opposite direction, and if the brake force is greater than the forward force, then the car will slow down. And finally, this glider here is moving at constant velocity because the drag force and the push force are equal and opposite. Okay, so they cancel each other out. It's going to result in 0 horizontal resultant force. It's going to either stay still or move at a constant velocity, which will move us into the next topic, which is Newton's second law.